In this lesson, we're going to seek to understand the meaning of a real number raised to an exponential power. We're also going to rewrite an expression from exponential notation form to radical form. To help you understand rational exponents, if you think of a plant or a tree, they get their power or their nutrients from the sun. So we're going to think of the sun as the power. So if you'll take a look at the line that is drawn, this just represents ground level. So below ground level of that plant, you have what is called the roots. So the roots will always be in the denominator of the fraction, and the power, which here represents the sun, will be at the top of the fraction as the numerator. So again, the top of the fraction is your power. That's what the sun here represents. And the bottom of a fraction represents the roots, and that's what it represents here in this picture representation. So again, whenever you see a number raised to a fraction or rational exponent, the numerator tells the power the number will be raised to, and the denominator tells the root that you will be solving. For example, square root, cube root, and so forth. So if you ever forget, just keep that diagram in mind, and you'll know that, again, the top represents the power, and the bottom of your fraction of the exponent represents the root. So if you were to rewrite that rational exponent into radical form, into like a root, whatever that number is, the base of that number will go under the radical symbol. The bottom tells you what root you're dealing with, so you make sure that your index, your number outside, coincides with the correct root that it should be. The power, which is on top of the fraction, tells you what you're going to raise that base to. So you can write it in this form. Another form you can write it in is the number, the power that it's raised to. You can put it on the outside. You can put your whole root in parentheses and then put your power, which is the top of the fraction, on the outside. And actually, as we start solving, you'll see that the second method of putting the power on the outside and solving the root first is actually quicker, in my opinion, to solving some of these expressions. So let's do some practice on converting rational exponents to radical notation. So we're going to start with x raised to the 1/2 power. So here the base in the big number is your x. That's going to go under the radical symbol. The top of the fraction is a 1, so you're raising it to a 1 power, which, by the way, when you raise a number to a 1 power, you don't even need to write it because we normally don't write ones there with variables. The bottom here is a 2. Anytime you see a 2, that stands for square root. Now with square root, we don't write the 2 there, but it's understood to be a 2 if you just leave the index blank outside. So this is how it would look to write that same expression in radical notation form. It would just simply be the square root of x. Let's do another one. We have 35 raised to the 1/3 power. So again, my base, my big number, 35 here, is going to go under the radical symbol. The 1 tells me you're raising it to 1 power. Anytime you're raising something to a 1 power, you don't need to write the 1. You only write the numbers that are greater than 1. The bottom is a 3, which tells me I'm going to be dealing with cube root because a 3 represents cube root. And so we simply just write the cube root of 35. And there you have it. We've written it in radical notation form. Let's do another one. Here we have c raised to the 3/4 power. So here at the top you have c is going to be raised to the 3rd power. And what type of root it's going to be? Well, if you look at the bottom, you see a 4, so that's going to be the 4th root. Now you can write that. This is the way you would write it in radical notation form. That is one of the ways you can write it, as seen in the very example at the top. The c is raised to the 3rd power. The top of the fraction always tells you what power you're going to raise it to. The bottom of the fraction tells you what root you're going to be dealing with. Now the other way you can write it, as I told you before, is you can write your radical and then put your power that is raised to on the outside. So your radical in parentheses, power on the outside, so it would look like so. Let's move on to our last example. In our last example, we have 10a raised to the 2/5 power. Now be careful with this because both terms are not, both terms do not have a rational exponent. Both terms don't have a fraction. Only the a. 10 does not have a fraction exponent, only a. So what you have here is 10 times a to the 2/5 power. So it's a to the 2/5 that you're going to rewrite as a radical. And then 10 is just going to be on the outside because it's being multiplied with it. Keep in mind here, we're going to raise that a to the 2nd power. And what type of root will this radical a have? It would have a 5th root. So when you write it in radical notation form, it's going to look like so. And recall the other option is that we can just write the radical, the 5th root of a, and then put the 2 on the outside in the upper right hand corner, with 10 still being on the outside because it's being multiplied with a to the 2/5 power. And there you have it. We have just succeeded in converting rational exponents to radical notation form. Okay, so now that we've had a little experience in rewriting expressions from rational exponent form to radical notation form, we're going to go one step further this time and actually solve the expressions. So I'm going to do a demo first, but keep in mind that for the rational exponents, the top represents the power and the bottom represents the root. So in this demonstration example here, I have 8 raised to the 2/3 power. So at the top of my fraction, I have a 2, which means 8 is going to be raised to the 2nd power. And the root that I'm going to be dealing with is a cube root. So recall, we can write it like so. That's one way you can write it. When you write it this way, let's go ahead and proceed with solving it. 8 squared means 8 times 8, which is 64. And then now we need to find the cube root of 64. The cube root of 64 is 4. And so there we have solved and evaluated the expression. Now let's do the same thing, but this time let's put the 2, the number that 8 is raised to, that power. Let's put the power on the outside because I want to show you that sometimes that way is much quicker, and in doing so you're not dealing with a very large number. So if we write that expression, instead of putting the 2 next to the 8, if we put our radical in parentheses and place the 2 outside in the upper corner, we can solve the root. The cube root of 8 is 2. That gives us a much smaller number. And so 2 squared means 2 times 2, which still gives us 4. Now you can certainly choose whatever method that works best for you or you understand the most. I'm just simply stating sometimes the second method can be quicker if you're not using a calculator, because you can find the root of that smaller number and then raise it to that power and get your answer, rather than have a big number that you have to find its root. But if you're using your calculator, then obviously the calculator will do all of the work for you. Let's do some more practice on evaluating expressions. In other words, actually solving them. So here we have 9 raised to the 1/2 power. And recall, anytime that the top number that it's raised to is a 1, we don't need to write that because it's not going to change the value of it. For example, 9 raised to the 1 power is still just 9. So we don't write it, you just leave it off. Let's take a look at the bottom. You see you have a 2, which indicates that square root. So all we need to do here is find the square root of 9. And the square root of 9 we know is 3. Next we have 125 raised to the 1/3 power. So here we're going to be dealing with cube root because you have the 3. So all I need to do is find the cube root of 125. And we know the cube root of 125 to be what? Yes, 5. Next we have negative 144 raised to the 1/2 power. Now the fact that we have a negative in front of the number means that whatever the answer would be, it's going to be negated. It's going to be a negative instead. So let's go ahead and just look at it first without the negative. We have 144 raised to the 1/2, which means that that's going to be square root. So all we need to do is find the square root of 144, and it's going to have a negative in front of that radical symbol. And we know the square root of 144 is 12, but with a negative in front of it, that will make it negative 12. Next, we have 16 raised to the 3/4 power. So 16, we're going to raise it to the 3rd power, and we can see here that we're going to be dealing with a 4th root. So I'm going to solve it, the radical expression first, and then I'm going to go ahead and raise it to the 3rd power. So the 4th root of 16 is 2. 2 cubed means multiplying the number 2 3 times, and that's going to give us 8. Next we have negative 81 raised to the 3/4 power. So that means that we're going to have, 81 will be raised to the 3rd power, and then we're going to be dealing with 4th root. We have that negative there, which means outside in front of the radical symbol, we're going to have a negative there. So it's going to look like so. We're going to go ahead and solve the radical. The 4th root of 81 is 3. And 3 cubed is 3 multiplied 3 times, which is going to give me 27. But the fact that it has a negative in front of it, it's going to equal negative 27. And there you have it. I'm sure you're doing very well. We have 4 more to go. So I want to take a look at a scenario when you have the number, and instead of outside, the negative is now inside the parentheses of the number. So when that is the case, that means the negative will follow with the number going underneath the radical sign. So here we have, for the first example, negative 25 raised to the 1/2 power, which means that's going to be square root because of the 2. So we're going to go ahead and write underneath the radical symbol the whole negative 25. Okay, so that's the difference. If you have the negative outside in front, then it will go outside in front. But if it's in a parentheses and it's inside enclosed, then you have to make sure that that negative goes with the number inside that radical symbol. And so now we're ready to solve the square root of negative 25. What is the answer to that? Well, you should know by now that even roots cannot have a negative underneath, because there is no number that when you multiply it twice will give you negative 25. So therefore the answer is not a real number. Now it is solvable once you learn about imaginary numbers, but we're not to that point now, so we're simply going to state that it's not a real number. Let's go to the next one. We have negative 32 raised to the 1/5 power. So that tells me we're going to be dealing with the 5th root. And again, because that negative is enclosed inside the parentheses, it's going to go under the radical symbol of that 5th root. So let's go ahead and solve it. The 5th root of negative 32, and yes, you can have a negative underneath an odd root. So the answer is not a real number. That's not the answer. So we're looking for a number that when we multiply it 5 times, it equals negative 32, and that number is negative 2. Moving on to the next one, we have a fraction raised to a fraction. Now, the fact that it has a fraction as its exponent, we have to treat it like a radical. And if you look at the bottom, it is 4th root, which means under the radical symbol of the 4th root, I'm going to place 16 over 625. Lastly, all I need to do is go ahead and find the 4th root of that fraction. Starting with the top, you're looking for a number that when you multiply it 4 times, it will equal 16. And for the bottom, you're looking for a number that when you multiply it 4 times will equal 625. Now it's going to be a fraction, and when you're done with the fraction, when you solve it, you don't need the radical symbol. So the answer is simply 2/5. Because if you were to multiply 2 4 times, you're going to get 16. If you multiply 5 4 times, you're going to get 625. Last example, I have 4 times x to the 1/2. And I want to rewrite that as a radical and then solve. Now, only the x has a rational exponent. Only x has a fraction, not 4. 4 is being multiplied with that x term. So we can only rewrite the x as a radical, and because it has a 2 under the bottom, that's square root. So it's just simply going to be the square root of x times 4. So the 4 is going to be on the outside. And there you have it. 4 times square root of x.